To all the Form 4 and Form 5 students, okay, whether you are KBSM or KSSM students, I would like to introduce to you, this is a very interesting topic that you must master for addition and math. Okay, this topic is function. Okay, so the syllabus for function is very interesting. Let's have a look for this hot application for the function in our daily life. Okay, so this is actually the latest Proton, okay, X70, which actually apply the function. Okay, so I would like to show to you all that the syllabus for function is very interesting and very creative nowadays. So if you are Form 4 or Form 5 students, please go through the syllabus, go through the whole chapter, read through, and it's actually very meaningful for you, especially for those who are taking addition and math. So you can just pause a video and read through all the information that I try to upload here. So it's interesting because the chapter come with a diagram and with the latest information. It's very up to date. So I feel very impressed about this topic because the way they present the information and also the diagram and the picture, which is so interesting. Okay, so let's go through together. Let's follow the chapter from beginning to the end. Okay, I hope you do enjoy the chapter that I share with you by using YouTube. You can also scan the QR code and you have the information about the objective of the learning for this topic, right? So okay, so there are so many history about the function you can go through and read through. All right, okay. So now actually my purpose of showing this chapter in this video is so that I can share to especially the Form 5 student, so that you know that there are many application for the function in our daily life. Okay, so I hope you find your interest in addition and math by studying this topic, because actually function is a very important topic for addition and math. Without functions, your addition and math cannot function. So for me, I think if you want to master the addition and math, your function must be master well first. So okay, so for the beginning of the chapter, they try to introduce the history of the mathematician that actually bring about the idea of the function. So they also actually show to you the important keywords that you need to master for this topic. Example of the keywords are object, image, and then domain, codomain. All these are important keywords for function. So okay, by looking at the keywords given, function notation, okay, undefined function, absolute value function, which is different from last time. Vertical line test, this one also different. Last time we don't have vertical line test. Okay, arrow diagram, yes, is the same. Object, image, domain, codomain are the same. Range also the same. Discrete function and continuous function are the new subtopic. Composite function still the same, inverse function still the same. The difference is a horizontal line test. Okay, so there are a few changes for the syllabus for function. So that means that students have to master the horizontal test and vertical line test so that they can master well the function. Okay, so for this function, they also bring about the idea of our national car, Malaysia's national car, which is Proton. Proton is the new model of the Proton XP70. Okay, so for your information, for the KSSM, you need to learn extra a few topics, which is actually absolute value function, and absolute value function is a modulus, and also vertical line test, and then horizontal line test. These are the three subtopics that you must master for the function, right? For the KBSM student, you can actually go through this topic because it's actually very, very meaningful for you to learn function through this way. Okay, I mean the way the knowledge sent to us is very different. So they try to present in an interesting, interactive way. So I'm very, very impressed about the new syllabus. Okay, so I hope I can share with you the new syllabus for the KSSM, so that the rest of the students also got chance to go through. Okay, so let's see again. Domain, you should know domain is actually a set consists of all the objects. Right now you can even scan the QR code and then you will have objective of the learning for this function. Okay, so now let's go through. Did you know that the subject of function was first introduced by the French mathematician René Descartes? I'm not sure how to read. In the year 1637, according to him, a French mathematician, according to him, René, okay, a function is any variable x where its power is a positive integer. Okay, its power is a positive integer. This is according to René. Any variable x where its power is a positive integer. However, Leonhard Euler, a mathematician from Switzerland, stated that a function is any equation or formula involving variables and constants. His idea regarding this, was accepted, and then the significance of this chapter, how important is this chapter? A function gives rise to simple and accurate mathematical model in representing a situation as well as in solving problems faced in our surroundings. For example, the height of an individual h is a function related to his or her thigh bones f. By substituting the value of f into the function h, forensic experts are able to estimate the height of a corpse based on his or her thigh bones. This is very interesting. Bank officials use a concept of function in calculating the interest incurred in a loan, and hence in the installments of purchasing a house, a car, a personal or business loan of their client. So please scan the QR code to watch a video on the Proton X70. Actually, I just show you at the beginning of the chapter. Okay, let's say for the function, there are many quantities which depend on one or more variable in our daily life. So study and then understand the following situation. All these are actually hot example in our daily life. So you can go through the picture. You are working as a temporary cashier and is paid RM80 daily, 80. The total payment received is determined by the number of days you work. You are buying durians from a store. If the cost of 1 kilogram of durian is 8 ringgit, the total amount you need to pay depends on the weight of durian. Okay, so all these are actually a function. In mathematics, such a situation are example of functions. Do you know that? From the above example of the statistics, state the function. Okay, you can try to express in function notation. And then for this topic, you also must know how to explain the functions by graphical representation and notation. So you must understand what is graphical representation and function notation. That means you must know how to use graph. You must know how to use a symbol so that you can write the function notation. Okay, so you can have a look of the graph. This is y equal to 2x plus 1. On the right, the relation between the value of 1 on the x-axis and the value of 3 on the y-axis can be written as 1 map to 3. This indicates that 1 is the first element and 3 is the last element. So in this case, we can say that 1 is mapped to 3, map. Similar to 3 is mapped to 7 and 5 is mapped to 11, and so on. Every point x and y on the line is corresponding to the mapping of x is mapped to y, where x on the x-axis is mapped to y on the y-axis. So the relation of the function, okay, can be written, okay, as shown. So you can observe the graph carefully and then you try to understand what it means. It means by mapping x to y. Okay, so this topic is quite long because it comes with the introduction of the object image, and then you have to know what is domain, codomain, and also you must learn what is function notation, and then you have to know what is composite function and inverse function. Okay, so example of the mapping, this type of relation is known as function or mapping. So when we talk about mapping, or it can be say function. So each element x in the set x is mapped to the one and only one element y in set y. Very important keywords. One and only one element y. So function relating set x to set y is a special relation where x is an element of x is mapped to one and only one element. Y is element of Y. So please remember one and only one element, alright, for the Y. And function is special relation. Okay, so now let's see this one, how to write function notation. So if you look at the set, the function bring 1 to 3 and function bring 3 to 7, or you can say function map 5 to 11. Element 1 is known as the object and element 3 is the image. Similarly, 7 and 11 are the images of 3 and 5 respectively. Any element x in set X that is mapped to one element y in set Y by y equal to 2x plus 1 is written in function notation. So function notation, f with the semicolon x arrow to x plus 1 read as function f maps x to 2x plus 1. Function, okay, x for this example is read as 2x plus 1 is the image of x under the function f. Okay, 2x plus 1 is the image of x under function f, or the function of f bring x to the image of 2x plus 1. So these are the example that function maps x to the image 2x plus 1. So the object are 1, 3, 5 and the image are 3, 7, 11. So we can read as 2x plus 1 for 1 is 3 because 2x plus 1 is the image, and so on. Okay, these are the important information on how to read the function. So this is the example. I'll give you the example. You can try to answer. Are the following relation a function? Explain your answer. So I'll give you a few questions so you can go through. Function is a relation of 1 to 1 or a relation of many to 1. This is very important. Please highlight. Many to 1 or 1 to 1. Classification of animals, example. Favorite subject, this is many to 1. All these are function, right? Relation of many to 1. Relation of 1 to 1 are function. Okay, please remember. Not only 1 to 1, many to 1 also belongs to function. Okay, so example, the favorite subject of Ali is physics. Favorite subject of Rama and Tan is chemistry. Okay, alright, so now we can see that the relation is a function because each object has only one image. Okay, so you can see that the relation, if the relation is not a function because it does not satisfy the condition of being a function, that each object has only one image. Remember that for function, each object has only one image. So the function is defined as each object has only one image. Okay, please remember the sentence so that you can explain your answer later, right? Okay, so then highlight the important keywords. Now for this topic also, you must know what is the vertical line test. How can we determine whether a graph of a relation is a function? When a graph is given, we use a vertical line test to determine whether the given graph is a function or otherwise. If the vertical line cuts only at one point on the graph, then the relation is a function. On the other hand, if the vertical line does not cut the graph at any point or cuts more than one point, then the graph is not a function. Okay, so please highlight the important keywords. The most important keyword is the graph. Okay, you want to determine whether the graph is a function or not, you must draw the vertical line. Okay, this is called vertical line test. So the graph of h is not a function because the vertical line, it seems like cutting at the two places. Okay, the graph of h is a function for the left hand side, but for the right hand side it is not a function. Okay, so if the vertical line does not cut the graph at any point or cut more than one point, then the graph is not a function. Does not cut. Okay, if the vertical line cuts only at one point, then the graph is the function. Please remember the sentence again. If the vertical line cut only at one point on the graph, then the relation is a function. Okay, if the vertical line does not cut the graph at any point or cut more than one point, then the graph is not a function. Okay, please take notes and highlight. It's very important. So as you see, just now I say the graph of h is a function for the left hand side that I take because the vertical test cut at one point. So now for example 2, which of the following is represent a function? So you need to draw a vertical line. Okay, for A, it seems like the line cuts the graph at only one point, except when x equal to 1, where the line does not cut any point at the graph. Okay, so for the vertical line test, it's shown that for A, the graph is a function. For B, the graph is a function because, again, the vertical line cuts the graph at only one point. The graph for the C is not a function because when the vertical line test is carried out, the line cut the graph at 2 points. So you have to, okay, let's see the mind challenge. How many x-intercepts? Okay, you just read through later. Observe the graph in example 2a. The graph is for the function fx equal to x over x minus 1. From the graph in diagram, we obtain that, okay, let's see, when x approach the I positive, okay, that is approaches non-terminating. Okay, so let's see how the graph approach when it will be never touch the line x equal to 1. Therefore, this function is not defined at x equal to 1. Okay, because it don't have any value at x equal to 1 for this function. So next, let's observe the graph in example 2b. The graph represent the function is absolute value fx modulus equal to modulus x plus 1. We call as absolute. The expression of the absolute value with the two line x is the numerical value of x and is defined as okay, so you see if x more than equal 0 for positive x, negative x for x less than 0. So the function which defined by fx equal to modulo x, okay, is a V shape. It's a V shape, please remember. It must be a V shape. Alright. So when the x approaches the I minus, there's I minus, isn't it? I of 1. It means that x approaches the, okay, let's see example 3. Based on the diagram on the right, write the function notation. So you have to know how to express the function notation also. So you have to determine whether each of the following graph is a function by using vertical line test. This is the one that I discussed just now. By using the function notation, represent h in terms of x. Okay, so you try to write the function notation. Alright, so for this function, you also must know how to determine the domain and range of function. Alright, so it's actually very interesting topic. So let's say for situation 1, function y equal to 18x represent the price of the tickets. Okay, you can pause the video and have a look. And situation 2, a packet of popcorn contains 60 calories. Y calories is the function of x packet of popcorn consumed. Draw the graph for the function for the purchasing price. Okay, and then situation 3 is Hilal cycle a distance of 100 meters from friend's house at the speed of 10 meters per second. Okay, with the same speed, Hilal cycle to school. So you can draw the speed time graph for Hilal's journey. So all these are actually inquiry, and it is very interesting. In general, the domain of a function is the set of possible values of x which defines a function. Various range is a set of values of y that are obtained by substituting all the possible values of the x. After you substitute, that means they are all the values of the y. Then we will have to learn what is discrete function and what is continuous function. So discrete function, you can see that the range actually in terms of a number, okay, is usually integer. And then for continuous function, you can see the range are continuous. You can see there is a line showing that the range must be continuous. So in this function, the elements in set x are mapped for a corresponding elements in set y, okay, respectively. So look at the arrow diagram of the discrete function f. Okay, the elements in set x are the values of x that can be substituting in y, which is known as the domain. Various elements of set y are the possible obtained values of function f, which is known as codomain. The elements in set y that are mapped from x are actually the actual obtained values of function f, is known as the range. Okay, so you must understand what is domain, what is codomain, and what is the range, right? So please study the domain in green letter words, so you can have a better understanding of the domain. Okay. For the discrete function, set x is mapped to a corresponding element in set y respectively, and then the value of x can be substituted in f, okay, which is known as the domain. Various the elements of set y are the possible obtained values of function f, which is known as codomain. Okay, so again I say arrange. Okay, now you see the domain is 1, 2, 3, 4, and the codomain is 3, 5, 7, 9, 11, and the range are the one map with the object 3, 5, 7, 9. Next, consider a continuous one. Okay, let's see the continuous function. Okay, discrete and continuous function, they have different range. So now you're asking to determine domain, codomain, and range of the discrete function and continuous function. So for domain, you can list out in a set form PQRS. For codomain is 1, 3, 4, 7, 9, and range is the one map with the arrow 1, 3, 7, 9. Okay. For the next one, we'll discuss the function. F is defined as fx equal to absolute 2x minus 1. So you're asking to sketch a graph for the function. Alright, you're asking to sketch a graph for the function. The graph of fx is given modulus 2x minus 1. Can be sketched by plotting the table first. You plot the table first, substitute the x, then you find all the points, then you sketch a graph, and the graph will be a V shape. Okay, it should be a V shape with a vertex, with one vertex. So for this one, the vertex is actually the x-intercept is 1 over 2 and 0. Okay, so I think for the absolute value graph, you will get a V-shaped graph. By using the GeoGebra software, you can try to sketch. Okay, if you are free, you can try to sketch the modulus graph, or we say absolute value graph. So the range of the absolute graph, okay, is actually the value of the function. So the one that I highlight in purple color are the range of the function. So it's from 0 to 3. So you must know how to write in terms of the inequality. Okay, inequality. So you can try to determine the domain, codomain, and range for the following functions, and then you try to sketch the absolute function given, and you can actually check the answer at the back. Alright, so I think I will stop here. I will continue the lesson in next video. After you do the exercise, you can check the answer at the back of the video, because I actually try to upload the whole chapter of this function, and also I try to upload the answer for you to double check when you do the exercise. Okay, I also try to upload the example, which I think is very useful for those student who is now Form 5, that you can try to do all the exercise for this Form 4 textbook, because the questions are very interesting and very nice. Okay, because actually the best hot question that you can find is using the Form 4 textbook. Try to spend some time, okay, to do more exercise using the Form 4 textbook. Then I'm sure you can do well for your SPM. In case they set the hot question, the question will be more aligned like this. Alright, it should be the same pattern, because hot question for this chapter are very interesting. So I actually give you all the exercise that I can. I try to screenshot and then make it in the video form, so that you can try your best to answer. Alright, so I think I stop here. So I will continue the next teaching video for composite function, inverse function, and also the application of the hot question. So for today, I just share with you what is object, image, the range, what is absolute function, what is discrete function, and also continuous function, how to find the range. Okay, I also share with you different type of the relation and how to define function, which are very important concept that you must master for this topic. Alright, okay, with that I end my video here. Okay, thank you for following me. Okay, have a nice day. Bye, see you all.